On the topic of electric resistance, look at this question. There is a circuit diagram in which resistance are connected in this way. Now you have to find out the net resistance of the circuit between point A and B. It means battery is connected across point A and B, and you have to find out net resistance of this circuit in this case. How will you find out? Try it by yourself and then watch my solution. If we observe the circuit, we find that 4 ohm and 2 ohm resistors are connected in series. We represent this point as D and this point as E. So we can find out the net resistance in path ADE, which will be series combination of these two resistors. So net resistance of path ADE, RADE will be 4 plus 2 equal to 6 ohm. Now we draw the modified circuit diagram for this circuit. Between point A and E, a 5 ohm resistance is connected. And between same AE point, the resultant of these two resistance is also connected. That means 6 ohm resistance is also connected between these 2 points. It means 6 ohm resistance and 5 ohm resistance are in parallel because they are connected to two same points. Now the net resistance between point AE will be parallel combination of these two resistance. So the net resistance RAE will be product of these two resistance divided by sum of these two resistance, means 30 by 11 ohm. Now this is the new modified circuit diagram. Between point A and E, this resistance 30 by 11 ohm is connected, and the rest of the two resistance is connected in the same way. Now we observe that resistance between AE and EB are in series. So we can add them as a series combination of resistance. And their resultant is then in parallel to 6 ohm resistance. And then we can solve for the net resistance of the circuit. So the net resistance of REB branch will be series combination of these two resistance, means 30 by 11 plus 3. On solving it, we find that this resistance is 63 by 11 ohm. Now between point AB, these two resistance are connected in parallel. One 63 by 11 ohm and another is 6 ohm. Now these two resistance are in parallel combination. Therefore, we can easily find out their resultant by the parallel combination of resistance formula. So the net resistance of these two resistors will be product of these two resistance divided by sum of these two resistance. If we solve this expression, the final answer will be 126 by 43 ohm resistance. So the net resistance of this circuit is 126 by 43 ohm.